Hello YouTube, and here you can see an LED dimming bright and slowly gradually dimming. Now we live in 2022 and therefore to achieve this we often use things like Arduinos or a microcontroller or even a Raspberry Pi PWM output, and using an analog output control we get that effect. However, that is cheating. That is also not great at the moment because of the chip shortage and you can't get actual microcontrollers. So instead this is all being done with old school analog op amps and 555 timers. You just get it in a PWM effect. So for those of you not in the know, these are 555 timers. There's one, there's two, and these produce a square wave output on pin 3 using a capacitor and resistor. And then this is a 741. Ugh, whoa, look at that. 741 op amp. There you go, 741 at the bottom. That's really cool. And that is a operational amplifier with 2 inputs. And I'll just draw what's going on. So this is your typical 555 timer. Of course, I've driven it really badly and not to scale. But you've got your little notch there, which indicates to the left of that, or anti-clockwise, is pin 1. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no 9. 5, 6, 7, 8. Power is applied between pins 8 and 1. So 8 is positive, ground is on 1. And then you've got the old resistor chain. So you've got ground up, positive voltage up here. Oh, it's really weird to do this on looking through a screen. Ground through here. Ground. Power is through here. Then you got your first resistor to pin 7. Resistor across 7 to 6. And then there's a link going from pin 2 to 6. And then your cap. So if you draw this out in simplistic view, you've got power there, you've got your other resistor, and you've got your cap. And then you've got your chip sitting here, pins 6 and 7, and this is also 2, like that, like that. And then what happens is your capacitor charges up through both resistors. This is your trigger point, it triggers, and then it discharges through this resistor. So current flows in through both resistors and out through this resistor. So your on time is them 2 resistors, your off time is just that one. So if you choose a low value for this and a high value for this, you get roughly a 50-50 mark space ratio on the output pin, which is going to be a clock pulse like that. And your mark space ratio is the difference between your on period and your off period. Simple, right? Here I've got my scope probe connected, and I've got it connected to the top of this capacitor, which is this capacitor here. So you should see this charge up and discharge. If you look, you can see it charging up and discharging. And then if you look at the output, which is pin 3, now there's a scope probe on pin 3, looking at the output, which is this one here, which would be a clock output. And you can see the clock output coincides with the charging and discharging of the capacitor. So as the capacitor discharges, it's off. As it charges, it's on. In fact, you can line them up a little bit better. So you can see exactly the on and off time is related to the capacitor charging. So this chip produces a clock output for an RC network, resistor capacitor network. Great. But how can we make it do other stuff? And one of the ways we can make it do other stuff and produce a PWM output is with this chip. And this is a 741 op amp, or operational amplifier. And that is, the symbol of that looks like this. And effectively, the difference in signal, the difference in voltage between these 2 pins is the output. So these are positive and negative. So if we've got 0 volts here and minus minus voltage on here, the output will be negative. And if it's 0 volts in here and a positive voltage on this input, it will be positive. Probably said that wrong, but hey ho, it is along them lines. But anyway, what we're doing here is we are feeding in a triangle wave in one pin and a clock pulse in another pin. Actually, I've done that wrong. So here, this is a very fast triangle wave, And here we're doing a control voltage, so we've got a very slow triangle wave. And there's a reason for that. And then using that output, we will get a PWM signal. Now the reason for that is how the waves overlap, which I'll show you on the scope, it'll be easier. So how do we get triangle wave from one of these? Well, that's a triangle wave, isn't it? On pin 2 on that capacitor. So there's one, and that's a fast triangle wave. And for our slow wave, we just increase the value of this capacitor and increase the value of these resistors to get a long couple of second duration pulse. And then that goes in to a big resistor and a capacitor. And then what that will do effectively is smooth out that transition. So as this goes high, this will then charge this capacitor up, so the voltage in here will slowly rise. As it goes low, it will discharge that capacitor, so it will slowly fall. And we get eventually a triangle wave. And of course the current there is flowing this way and that way. And on this side we need to have a high impedance load. So this has got to be, you know, giga ohms. Fortunately, the inputs of an op amp are giga ohms, so that can go straight into there. There, even. Simple. And we can see that here. So the yellow line is the one that's jumping up and down. That's the output of the 555 timer, the square wave. And the blue line is the capacitor. You see it slowly charging and discharging when that line changes. If we zoom out in time, we should be able to see a triangle wave being produced on the blue line. And then the yellow line will be the clock pulse. Just wait. Wait. See how good I'm keeping my camera still. There you go. There's a triangle wave produced by a square wave. Here what we're looking at is the two inputs of the op amp. These two inputs and the output. Output's here. And this is what we get. So the yellow is our PWM signal. And you can see the pulse width changing, which is exactly what we want. This is our fixed triangle wave, which is our input. This is our slow triangle wave, which is like our control voltage. And you see where these two lines intersect is the width of the PWM. Because of course that is where the op amp switches state from high to low and produces our side. Because it's constantly changing, that point in which it changes is getting smaller and increasing because it's a triangle. See? Simple. And then what you can do is by changing the resistor values, so I put a pot in here, you can change the speed at which things go. So if there's that slowed it right down and the dimming effect is a lot slower. And what I've effectively done is lengthened the slow triangle wave or the control voltage into the op amp. And then I can speed it up and make it go quicker. There you go. So if you're affected by the chip shortage, don't buy Arduinos and Raspberry Pis. Just build it out of analog, because you can do it. I mean, I'm not saying this is practical. This is not practical, but it's kind of a cool idea. So you can see it takes a lot more room, but you're not, you know, have a play. At least you learn something. Hope you found that interesting, or if not, that's a little bit different to what I normally do because I've drawn pictures and pictures are cool. Yeah, let me know, and I shall speak to you next time. Bye for now. Green.